vaadake järgmist, kas räägib, et
räägi midagi vahepeal, siis saavad inimesed öelda. Siigi ei kõlab veel üle.
One sec. Alright, hello everyone. Let's begin with today's workshop without any work on your side. Yeah. So as promised, the new Ludum Dare event is coming really soon. This weekend it should be, and I promised to create this talk about some practical tips in Unity of how to structuring in your game better so it won't get so messy so quickly. And these tips are also applicable for game jams, because usually the simpler the method, the better it is. Those methods aren't really complicated, but I still hope there are some tips for everyone to get something you didn't know before. And yeah, if many of these of those things can be familiar to you if you have developed Unity games for years, but maybe there are some new stuff as well. So today I'm starting to make a game completely from scratch, and describing what I'm doing and why I'm doing it as I do. So unfortunately the Unity version here is a bit old, so let's hope it works.
Do you accept questions during the presentation?
Yeah, do you have any questions in the meantime? You may ask now. Yeah, dynamic some fonts as well. I should have them here. Alright, so in this project I'm using some open or free game art from Kenny. He's an awesome guy. He has several complete graphics packs available for free, and some that he sells for money as well. But yeah, so I want those fonts as well. So I'm using his pixel art fonts. Oh god. Just quickly importing them. And I'm using his pixel art sprites that he has many thousands on this sprite sheet apparently. I just want to take this. And so if you want to use the same things at home, Kenny is the guy, Kenny Assets. You can Google, and here it has several pages of different assets. I'm using this 1-bit pack currently. This is the one I'm using. Alright. I want to have this one as well. Alright, now I'm ready to start. I have all the assets I need. Yeah, I've separated those assets from this spreadsheet, imported the fonts, and we have the empty prefab folder and empty scenes folder. So let's create some other folders from scripts, and one for graphics as well. Ah, this is this is very old Unity version. The old editor, Unity current versions don't allow to change the font. I can probably just change the resolution. Maybe because I know this is really small and hard to see. Oh, that's much better. Is the stream still like okay? It seems that something is still going. All right. Can you see now?
Yeah.
All right. Just I have a little bit less screen estate. All right. So what I want to do is a. Let me open it somewhere here. I just want to take a different background color from this one. Let's sample it from here. All right. So what we want to have here, we want to make this simple shop system that's in video games is usually quite tricky to make and quite error prone and see what methods we can apply on it. So some things we might need are, we need some character. We definitely need some shopkeeper. Let's use this guy from here. Okay, the sprites are a little bit small. To make them bigger, let's change the pixels per unit to like 0.5. Oh. All right, so one guy is now half a unit. Actually, we can make it larger so it can be better. One guy should be one tile big. Also, it's a pixel art game, so let's turn off the compression and make it the filter mode to be point. Nice and pixely. All right, what else do we need? And we need we need some money, and we need a different colored character. This one. All right, that's all we need for now. So yeah, let's run it. That's perfectly, we have all these guys in the game. So first things first, let's make this character to collect these coins and make let's make it the like your money amount written on the screen. Something very simple. So some scripts we might need are for the player, for the coin, we need something to control our UI, so head-up display, HUD, these are controlling our UI, and we also need something called events, and this is part of this practice why we are using the events class. So first of all, the player needs a very simple movement logic. Now Unity, who doesn't know it yet, Unity has this input system built into it. So if you go edit, project settings and input, in newer version it can be in a little bit different place. Then Unity also defines a lot of different input options for you, and in the for like basic like keys and mouse clicks and escape keys and etc. and scroll wheel. For example, the horizontal input is mapped to the A and D keyboard keys. Also, left and right mouse buttons are alternatives. So, to implement movement very easily, we can simply write this transform the position equal and let's add input, get axis, copy this exact name. This is the value we are importing times time dot delta time. Because this input is float from -1 to 1, we need to convert it to vector. So this is on x direction and x direction only, and on y direction the same thing, just we change the y coordinate and it's called vertical. Alright, let's quickly add a speed, and that's also increase it, the movement speed a bit. And we should have our player moving. Which one it is? This one. Player. Let's give it the player script. Speed is 4. Let's also give it the rigid body, but it's a kinematic, so it won't control our physics. And let's give it a post collider 2D, so it can collide later. Alright, and now we should be able to move it around with our mouse. That's exactly what happens. So now very quickly let's implement this coin as well. We have this coin, we give it the coin script. Let's make both prefabs so we won't forget. So we can add more coins to the scene. The coin, it also needs a box collider 2D. Oops. A box collider 2D is set. Is trigger, so it won't physically trigger but can detect the collision, and apply it to the prefab. So and on coin we can simply implement Unity messages on trigger enter 2D, and currently let's just write something coin and let's destroy it.
What was the shortcut for opening the functions?
Yeah, so it's right mouse button. If you have Unity tools installed, then implement Unity messages. Shows you all the possible mono behavior like methods that you can pretty much like implement. You don't use the override keyword, but it's just Unity will understand that you want to have update or awake or whatever you have there. Currently we are using on trigger enter that collides when triggers when something collides with it, and you can see it's how this works. Those things are disappearing. Let's call this one shop. So wait, yeah. All right. So now is the question: how do we add the money? Oh, okay. Let's make the money. Let's make the easy stuff first. So let's make the money canvas as well. So UI. Oh, I have Text Mesh Pro. Very good. I strongly recommend to use Text Mesh Pro. It's almost as simple as regular text, but it looks like 1,000 times better. So yeah, I've just added a canvas with a Text Mesh Pro text. Let's call it a money text. This is very old version of Unity, so I hope everything works. So money 9999. So we have some text. That attach it to the left corner. I need a bit from. Let's make a little bit smaller, like 20. Alright, that's it. Also, let's give it a little bit better name. So color. So after all, we want to make a stylish game, not just some random game. Alright, we have this text. We have our heart that we can add to the canvas. And inside heart script, we'll add the Text Mesh Pro. Only thing that's a little bit more complex for the Text Mesh Pro is the name of the text. As you can see, it's a Text Mesh Pro GUI. I always forgot it and I need to Google it up. So money text goes here. So, and we have to import Text Mesh Pro. Alright, so we have this text and so we can change the name. So please update. I just have to do public. Alright, let's make it public. Alright. Now we have this money here, we have the reference, so we can do whatever we want to. So now the question is, we collect the coin, somehow the player must know about the coin, somehow the UI must know about the change of the money. So the way to do it, you can do it through like singletons and just manually change the like make the canvas like the hard singleton, so you can access from everywhere and just manually change the number of coins there. And that's something I've done for years myself, but this gets really messy really fast. Because every time you change something, you need to remember that where you what are the things you also did with it. So you always need to remember to change the GUI as well as when you increase or decrease the money value. And after you open up the script in after about a month has passed, I can promise you won't remember anything about the script, and you pretty much need to relearn it. So instead, use something like events. So we have this events class. This is not a bono behavior, this is just a regular class. We can even make this class static. So we just have a class somewhere but that we don't even need to have in our scene or anything. We have a static class that we can access from everywhere that has bunch of static methods. And now we want to use a C# built-in construct called events. So we define events for changing our score. So public, static, and the events are made with a keyword event. We give the name on money change, for example. And events are 1 second.
You need a action keyword.
Oh yeah, my mistake. Yeah, so the events are, yeah, it also needs an action keyword, and the action comes from the system namespace. And so the event are the actions, like these are like runnable methods, and here we define all the arguments of it. So currently it has float. And to make the calling of the event really simple, we also add some syntactic sugar. So we had public static method void for changing the money. Change money. I usually like to name the things the same, so the action just has the on keyword, change money. And now we can use some additional syntactic sugar. We can define it, so we can define the implementation of this method here with this lambda, I guess it is. So change money equals, or what this method does, it on change money dot invokes the method with the same argument. So and also the on change money might not be, you might not use this event anywhere. So just in case, we can always add this null pointer check here. So if the on change money event isn't bound anywhere, we won't invoke it. So now we have an event for changing the amount of money. Let's quickly make an other event for asking about how much money do we have. So if we want to define a function that returns anything, then we need to use func instead of action, and here on request money. So the request is like convention I'm using for asking for values. Request money, type is float, doesn't get anything in. And just invokes it. Now it starts telling us some mistakes, and it says that this one here wants to return float, or like a nullable float instead of regular float, so we can't assign it. So that's because we are using this null pointer check here. So if it's not assigned, if this event is or this function is not bound anywhere, it returns zero, it returns null, and so the value type is float. But we can quickly fix it with another clever syntactic sugar and adding this like default value check here. So if this one gives us null value, then we return just 0. and convert it back to the regular float. Alright, so now we have defined events for changing the money and requesting the amount of money. So let's see how it can be used. So first of all, whenever we collect a coin, instead of writing something to console, we will call this event. So events and on change money, and let's just put one there. Actually, instead of float, I like to use int here, so we have a okay. Okay. I don't change money. The change money is the method that allows us to very simply call it. So here we are calling this event, and now in any other object in our scene we can listen this event. For example, in our HUD. And listening should be, or binding this event should be done in the awake and on destroy method. Or so. Actually, let me just wait. And to bind this event, okay, we have this public. Let me remove those other methods, they're distracting a bit. Private. Change money. So we have a method for changing the money, which just changes the text. And inside awake, now we can have to bind this method to that event. So events on change money. Binding is like adding something to a list written in a similar way. And let's add this change money. Yeah, I mean just need this one. And we are not calling it, we're just binding this event with this name. And definitely you should not forget to destroy the binding. So always with an awake there should be a corresponding on destroy method with a opposite binding. So we'll always when this object will be destroyed, we will unbind it. So let's just add those two automatically, so we'll never forget to unbind this event. And now, as you can see, we can change the money to 1, and it works. Alright, so, but currently we don't keep track on the money anywhere. We are just adding it and removing it. So therefore we can't really change the money properly. Because we don't know how much money we have. So let's quickly add. Let's keep track of the money in the player class. Let's add the same methods here as well. Like in coin. Exactly the same thing, but instead of like changing some value, because we don't have UI here, we are just keeping the track of how much money do we have. So money equals I. And now the player knows about how much money do we have, and so we can also define define the request method. Private int request money, and this one should tell how much money do we have, returning money. And here we can find the request method. So on request money, is like that, and here we unbind it. So now the player will tell us about how much money do we have, because it keeps track of it. So now we know that we can keep the track of our money inside the coin method. We can simply ask how much money do we have. So 1 second. So here we will request the money first. Events dot on request money. Not on request, but just request. +1. So we ask how much money do we have, add 1, and set this one and change the money value to that. And now the money value is increasing, and now we have properly tracking the money. So a little bit more code than just making it a singleton and this way, but on the good side, none of these objects will know about each other. They only know about the events. So the event class, I'm typically using just one event class. If I need to, if it's becoming like too big, then I can define regions here. So like money region, so I can close some of the parts. But this class will give a very quick overview of what our system allows to do. So whenever another developer needs to change anything in the game, they can very simply like get a quick look at our money is implemented like that, and they can simply like call this method or bind this other method, and I don't have to know anything about the implementation of our coin or HUD or anything. So and also here I'm typically using like static events. You can also add like non-static like class events for objects if necessary, but not right now. All right, so we can collect the money, and that part is working. Also, the default money, maybe just in the like player start method. We can quickly just change the money to the original money amount. So we will start with the correct amount of money. Yeah, now it's 0 in the beginning. All right, so the next thing we would like to make a store where this guy here shows us different items that we can buy, and we can very easily buy them by clicking on them if we have enough money. So we have this shop one, and let's make a script for this shop. We also need an item, and let's make a script for the item. And because this item should only contain the data of the item, let's call it item data. I will later tell why it's item data. So, but yes, here we should store the item data. We also need a, let me think. Oh yeah, we need the item presenter. Something that's like the graphics of our item that shows how this item will look inside the game. So the item presenter pretty much follows the object, follows the data controller presenter pattern, where the presenter presents the item data. So that's pretty much where the naming convention comes from. Where it's pretty much the same that you're using the regular software development projects where you have this model view presenter. No, not model view presenter. Model presenter. Model view controller. Yeah, it's just used different wordings for the same thing. So currently, like our shop is serving as the controller that's controlling the data. So it has the data is controlling the is the data of our item, and the item presenter helps to present it. So and let's make a data folder as well. We'll need it soon. So let's begin with this data. The item data is something we want to predefine for a game, and for such things that we just want to define a lot of data or a game, the easiest method for using it is use scriptable objects. So the scriptable object is pretty much something that you can't add in your scene, but instead you can make assets of or assets in somewhere in a folder. So it's like way to store stuff in your assets folder, like game assets. And here we just want to define the data of our items. So the item has a name, it has value, and it has a sprite, so image of this data. To easily create it, this asset, we need to create this menu listing for the Unity. So we need to add this create asset menu keyword here, so it's under the data/item, for example. So what this thing does, if we go to the folder where we want to create the data, now if we press the right mouse button, then inside our create menu, it creates this data listing, and we can create our scriptable objects from this list. So it pretty much tells that this scriptable object is creatable through this list here. And so let's make some data. Let's make a sword. Let's I put the computer to sleep. What's the name of the user? In my home computer, the F2 is like F1, F2. I have, in order to press F2, I have to hold down F1 key. So it's like reversed. But here, on this claviature, it's the other one. So I will get really bad time.
Is the string
I don't know. It seems to be working. So let's quickly create some items, axes, swords, and bows. I forgot to make those public, otherwise they are not serializable. And So we have an axe, value of 1. Can we find from this tiny list an axe right very quickly? It should show more stuff.
Okay, you can search.
No, because those things don't have proper names. They're on B. That's going to be tricky. Okay. I accidentally got right. Actually, it might be easier to quickly just duplicate this one now. And here, this should be very close. So here we have a bow, and here we have a sword. Should be very close. Yeah, we have a sword. Progress right. Let's give them different values. So axis first of this bow. This is sword. Right. Also, if you want to add some item type here, like equipment or something like that, then in Unity, using enums is the simplest one. So let's just make the public enum. And we can have like weapons, armor, yeah, miscellaneous, some and it should have a name, item type. So we define an enum, and now, for example, if this item data also has item type, then and if this enum is public, so serializable, then we can simply in Unity Editor it shows up as a just a drop-down list, and it's very simple and clever trick to use if you haven't done it before. All right. Let's go back where we were left. So we have this item data defined. We have our shop, and inside the shop we should just define the list of stuff they sell. So public list item data items. So the list of items the shop sells. And here we have the shop. Add the shop script. There's an item list, and we can give it some items. So this one will have a bow and an axe, and that's it. And then it's not prefab, so let's make it prefab. Let's add a different shop that has like 3 swords. Can you give it different visuals as well? Alright, so we have two shops selling different things. So let's now see how we can present them. So to very simply add a list of things to the shop. Let's make wordspace UI. So let's make a new canvas, and let's call it the shop canvas. Yeah, so instead of screen space, let's make it a workspace. Let's give it the main camera. And yeah, now the scale of this canvas should be much smaller. We want to place it on top of it, so we want to make it the size of the unit. So let's make it 3 wide and 0.5 tall. Where is this shop canvas? Oh, not pause. And let's put it to the center. So now we have this small canvas here. We can just drag on top of this guy. And we can attach it to the guy. The shop. Now if you move the guy, it has this UI canvas on top of his head, and you can display whatever there. If you're making a game about having a health bar or something on top of your characters, then this is the easiest way of doing so. So this shop canvas should quickly have a panel. Let's just remove the source image. And this panel, we can add a horizontal layer trope. Let's not expand the width, that makes it center. And to that one, let's add a button. Oh damn, it's enormous. So let's have just a button. Like that. Actually, we want to give like an item to the button. Yeah. And so we add a button here. Now the only question is why. Yeah. And preserve aspects. It as well? No. And now if we make multiple of these, they'll it's an older Unity, in the newer one it behaves a little bit different. I assume. Let's make another one. UI button. Okay, like that. We have this item there. And now, because we are using the canvas, its layout will be correctly aligned. So this one here is our item presenter. And this should get the item presenter script, so that we are showing off. Now I can decide this one and make this item presenter to a prefab. So now let's see how we can show up how many items this guy has. The shop has the list of items. It also should know the panel where it should place the items in. So public game object item panel, and it should have a prefab so you can create multiple items. Public item presenter item prefab. Yeah. That's all it needs. And now in the start method we can start creating these items. So first of all, let's clear up this panel. So let's do through the children. And delete all the existing children. And then let's create new ones. So now we will look through the items list. And for each item data, we will create a new item prefab. We can call this one data because it's item data. So this is actually the item. So because this one is looking through the data, and now in the item data on the item one more script. No, we have the item presenter. Just haven't started editing it. And the item presenter should have a function for changing the item. So public void set item data. It will save the data that this object has. And it should set the sprite of this item to the proper one. That's right. Image. Image is in Unity UI namespace. It's UI element. Data.sprite. Alright, we are taking the sprite from the data. Sprite that is used to. Okay, I can't use this one here. So we just have to hope that we have this component. Otherwise, we are doomed. So yeah, and now the shop. That creates items should also tell the item to set the proper data. Alright, so the shop creates the items and the item presenter presents them, so shows the proper image. Does it work? Nope. An exception. Because we haven't assigned all the stuff we just added. The shop should have the item panel and item prefab from our assets. And let's apply. Oops. Alright. And now, at least it doesn't give us errors, but it doesn't show the items yet. Let's quickly see. The shop is here. It has the items, the panel, is empty. Do we go inside? Do we create this item at all? Yeah, we are creating the items. I forgot. This we need to assign those items to the panel. So we can just add a parent here. The panel should be the item panel. Transform. So we are assigning the items to the correct thing. Yeah, now we can see our guys here are having the right items that we have assigned them. And we can also click on them. Maybe see it's changing color a bit. Because these are buttons. So these are buttons, so what we can do, we can make the breast color darker, and we can make the disabled color less opaque. So we will see. Right, and now I can click on them, and maybe the click is a bit darker. But we actually can't buy all these items because we don't have money for some of them. So that's why it's very handy to have this money event already. So we have our item presenter, set item data. We can also listen to the same events that are hard tasks regarding to the changing the money value. And here we can, so we can make sure we can check how much money the player has. And instead of just changing the money or whatever else ever we did before, we can check here if I is smaller or equal. I is like the player money, how much money the player has. So if the money is more or equal than our data is worth, then everything is okay. And this button, let's get the button as well. Let's get the reference to the button in the awake. Then the button is not this button. Is interactive. Or else the button is not active. And we also keep in mind that inactive objects will not be the events will not activate for those. So we have to call this once in the start method as well. Oh no. Start in the set item data. We can simply call it ourselves events dot on request money. So yeah, we'll change it once when the item is created, and then whenever the money amount changes during the gameplay, it will also update. So let's see, it should work now. Or not. I have to make sure that the data is available. Alright, now we can see initially we don't have enough money for those items, but once we start gathering money, they become active. And yeah, that's it. Alright, and very quickly, it's also very simple. Let's make the purchasing possible. So let's make an event or variable by item. And this is just an event that will call whenever we press the button. And typically you might have used this for assigning buttons in Unity. You might have used this button graphical on-click method here, but actually it's much faster to do it in code, and instead of like manually set up them in Unity and then sometimes get broken. Use the Unity event system to assign it here. So button on click, add listener, change money, and so buy item. And whenever we click on the button, we will buy the item. And this is quite bulletproof. You have a script that always need to get reference to the button, so it's much better to do it in the code. And here we can just destroy the game objects. But not before we produce the money, otherwise we will have received the item for free. So events.change money, events.request money minus data.value. So we'll trigger another event about chasing the money, and everything simply works. So we get some coins, we buy swords, and we don't have enough money for the swords anymore, and we can nicely and easily purchase these items. Now, some of you might have been wondering if you have used, is it like, once you have like a lot of those events, because the next thing we would like to do is to create a new event for buying the item, and as well. So pretty much you can structure your game in such a way that none of the objects will have to become a singleton. So you don't just need to access any arbitrary object from a scene. Everything goes through those events. Only for the very very straight connection, like the shop knows about the shop item presenters go directly. It's obvious. But in such cases, those events can quickly become very numerous. And I looked it up. Some people have done tests in the internet, and actually calling this built-in C# event is only like 20 to 30% slower than direct interface call. So like directly calling through an interface is only like mildly faster, and in the grand scale it doesn't really make any difference. So unless it's like a very performance critical place where you're making a tiles of a level of a ground or terrain or something like that, then just throwing out a lot of events is not causing any real performance hit. All right. So now I don't know how much time I have left over. I'll give you two options of things you might want to show you in addition. So first option is do you want to see me implementing a confirmation check? So whenever the player purchases the item, before we show the confirmation screen, asking the player whether he actually is sure to buy the item or not. So does he actually want to buy? So this is one situation, and that's good pattern for and what we're using there is like the actions directly. So we would like to get the feedback back from the confirmation panel whether the confirmation panel was successful or unsuccessful. Another option for me is to implement a saving system using scriptable objects to save some game state in, or for example, the money or items to some scriptable objects. So which thing you want to see more?
Quick vote, with hands.
Yeah.
Confirmation window.
Oh, okay. We have the hands up round. So first of all, who wants to see the confirmation window implementation? One hand. And who wants to see the save game implementation? A lot of hands. All right. So.
Question.
Yeah.
Would you implement like an inventory system similarly, or would you do something different?
I will definitely use the scriptable objects. I've used the same item data there, and use and the inventory is just a different presenter for the items. So if I would do it now, I would do it so that I have this data somewhere. So I have. Like similarly as we did with money, we have this player who stored the actual money value, and then we had the presenter that's or the hard component that was displaying the money. So how I would do that, I would make another like container that's containing storing your inventory state. It just contains like a list or array of item datas. And I would make a separate like presenter, like UI component that's displaying it, displaying the items you have currently in the presenter. And in this way, the data isn't connected to some UI elements or some UI sprites. It's not representing the item, but it's stored somewhere in some class. And what I can do then is I can serialize this class and save it to the simply save it to the disk. So I will show the saving part right now, so you can see how it's done. So for saving, let's create some new classes. Let's create save controller, something that's controlling our save games, and let's create a let's create a class save data. Save data. So everything we want to save. So the save data, once again, is very similar to the item data. It's a scriptable object. We can get it from the menu. And why scriptable object, you may ask, but I'll show you it in a second. Why it's a good to have save, also something that you can save in your unit assets folder. And here we can add a list of item data, for example, like for inventory. So let's call them items. Make it public. And yeah, the list is by default serializable. Let me see if the item data is. It's not yet. Yeah, we can also store like money here. Integer is definitely serializable. Now we have to make sure that all the things that we store here are serializable, so we can store them on the disk. So currently, the save data itself isn't serializable. So we need to add the serializable keyword here. It uses the system. And now the save data is serializable, and also the item data is not yet serializable. So serializable means that this thing can be serialized into string or bytes or whatever you wish, and then you can use those bytes or string to save them on disk.
Or if you also want to save the shop data, how many stores with it?
Yeah. So then I have to make this one also dependent on something, some serializable data. So for example, I need to have something like this here and this shop data. Or I shall have something like this here, probably. I need to think about how it relates to the shop exactly, so the shop can't. Actually, I think I can even make the shop serializable itself. It might work. I might make the shop serializable this way. It has the item data that is serializable, and I don't really care about the other things, so these can I can just make them like private, like not private, but no. I can make it private and give it the show in inspector, so I won't even try to serialize these objects. Only the ones I need to. And here I can then just add a list of shops that will be serialized. But yeah, giving the back to the shops is a little bit tricky. I have to manually assign them backwards. But that's not take it so far yet. Okay, we have items and money in our save data, and we have our save presenter controller. So this is a thing that should be somewhere in the scene. So let's just make an empty game objects for like controllers and stuff. So save controller goes here, and the save controller what it does have is it should have like some save. And let's make this save public. So we have public save data save. Now in the start we don't need update, but we might need a methods for loading and saving. Autocorrect. We need methods for loading and saving. Let's make load game and save game methods. All right, we have this save data, and why it's like useful to have the have the save data as a public thing in here is that we can at the beginning of our game we can make it so that when we are testing our game, we can create a custom save data or we can create several custom save datas where we just casually assign us a lot of money and a lot of items, not currently not items, but yeah, a lot of money for testing and stuff we want to have, and assign this custom save data as our like default save for our game. So this way, and we can very easily like modify the save game inside Unity editor and make those custom save this way, like just like that. And now in the start, we can check if our save is 0, or is null. We don't have a custom save given, then we load like a normal people will do. They will load the save game, but otherwise we will just continue using the custom save we have. Now, okay, I don't have the save implemented yet, but load implemented yet. But let's begin with the save. So how do we save the game? Now, usually in Unity, you would like to save stuff in the persistent data path and etc., where you can simply save it inside some file. So for simplicity, I'm skipping all the file reading and writing and file checks, and I'm saving stuff just to the player preferences. So this is like a Unity version of HTML5 local storage. You can simply save some strings there, some stuff there. So you can very similarly just save some stuff into the persistent data path and in some files. But let's make it a little bit easier and save it in the user player prefs. So player prefs goes to the player prefs class, and it has some simple parameters like set string. So yeah, you can save it in the string. We are saving it the string there. So it gets the key as a first argument. So let's call it the save, and the second one is whatever data we want to save to that key. And that data we can get from the save. So save. So we now have to serialize the save into a string, and for that we can use the JSON utility and use from to JSON and just pass the save game here, and that saves the save to that location. Let's also log out that we have successfully saved it. Game saved. So that saves the save game to the disk. We just make this needs that our game like save data is serializable. But if everything is serializable, then it's all done for us. Let's very quickly implement some buttons for testing the save and load. Typically, I would make custom events for that, like save game, load game, and listen to those events. But just to save some time, I'm doing in the same class. So if input booked get key down, if you press L key, then we will load game, and if you press S key, then we will save game. Okay, and now we can test it. We can see that at least we are triggering the method, and hopefully we have something in our local storage. Inside our load game, let's try to load it. So here we first have to check whether we have this save game existing in our local player prefs, not local storage. So if player prefs has a key save, then we know that we at least have something saved there. Otherwise, we can save whatever we currently have, for example. So we can save the game. All right, but right now, and in the beginning of the game, if we don't have a save, then we will load. We'll load the game. So right now it works. Or
S is probably conflicting with movement. S key. Can you say it?
Oh yeah, I have S for movement. Let's use U for example. U saves, L at least loads. Okay, but what happens if we remove the initial data? We'll get an error. Null reference. We can't save. It's not a real problem here yet. So 1 sec. To null pointed checks there. So this was the real problem. Okay, we can load, we can save, but the question is, what data do we have? We don't have any because we didn't have it previously, and we can't really like load it in because we haven't anything saved yet. So we have some need some custom default data. So whenever we try to save the game, but we don't have anything to save, then we should create an empty save game. So if save equals null, then we need to now create a scriptable object from scratch. So we might try to just save equals new save data. It doesn't work. It should give us some errors. Let's see. Why? I have to try to save as well. So yeah, we get error that our scripter create a typical create method doesn't work. We have to make scriptable objects through scriptable objects create instance constructor. So that's what I expected to see. So instead we have to use scriptable object create instance save data. But this allows you to create like data runtime. This scriptable object is also quite useful if you want to make like modding support for a game. You make the items exactly as we did here, for example, but you'll implement the way to like dynamically read and create those item files from files as well. So this way the players can make their own item files and modding will simply work. Not simply, you still need to put some effort to developing it, but yeah. Now it creates the save data properly. Okay, loading is left. So for loading, we need to reconstruct this scriptable object. So once again, we can't directly just load it. We need to make a we need to create a new scriptable object, and then we need to read backwards from the player prefabs. So player prefs get string and save, and now we need to convert this string into this scriptable object, and this goes through the JSON utility, and we usually if it's a regular string or something you want to read, you can use the from JSON, and it just returns the string or whatever. But in this case, we need to use the from JSON overwrite. First argument is JSON, and the second one is the scriptable object. This is necessary because it's a scriptable object that we can't just create on fly with a new keyword. And now we have filled in the save, and we can just overwrite our current game save and tell that the game has been loaded. Moreover, every time we load the game, we want to also update the actual game state, update game. So whenever we load, we also will update the game, and also in the beginning of the game, if we just use the default one, we will also update the game for once for the default state. So we will update the game for once, and what we'll do for the update, we have our event system. So events, we change money to be the save money. Let's just only use the money for now. Now just quickly check if I'm using this killer save game for debugging. Then I will starting with a lot of money. And now let's see if you don't have a save game. We are saving, we are loading. So when we are loading, the money value changes. But the question is, do we have a proper, what's that? Do we actually have the correct one? So we are saving and loading, and for some reason, even if you're saving for now and loading here, it doesn't, the save has reverted back to something something regular. So quickly okay,
When you're saving the game, you're not if the save in the save game function. If you're creating the new instance, you're not setting the money value. The save instance.
then the save will have a zero money. So save dot money equals we can go custom. Just try to change it from 1. Yeah, this one doesn't mess anything up. I have. It shows that the game is saved. Let me very quickly just show what do we have inside this player preferences, because this toString didn't work apparently. All right, we have. In the player preferences, we have the save game with items and money with money 0. And let me very quickly log it here as well. Okay, if I'm taking some and pressing save. My save game state. I'm never updating the money value in my save game state. So let's just you can do it definitely a little better. But the save game also need to be listening about the money save. So very quickly, this is right now it's getting messy, but I know how to fix it at least.
Can't the save game request money?
Yeah, I need to make it so.
Before you actually save it to the player preference.
Yeah, I can do it right here. So save.money equals events dot request money. All right, now we should have some proper saving. All right, money is 0. Saving money with 1 and loading, and money stays 1. So we have, so now I'm just taking pieces, loading once again, and we can see that the money reverts back to the where we saved. So yeah, we have kind of implemented a very rough save system. Yeah, for keeping track of those exact values. What you can do is instead of even keeping the money value on your player, you can move this money keeping track of money part all to the some save controller where you're directly updating the save data always. So your save data will always keep track of all the values and information you have in the game. Instead, keeping it track in the player and also in the save game. Or if you like to keep it in the player, it's also valid. Then you just need to before saving you have to request all the data you have to save. Ask it from other objects and save it successfully. But this event system in general makes it much prettier. and currently I didn't make any other events, but at home for the same project I made 6 or 7 different events for keeping track of buying the objects. That there was buy event. There were these events for asking for opening up this confirmation window. So then just calling event that it opens up with this window with proper data. There were events for saving and loading and etc. So and this event-based system it's especially useful for all the UI stuff. So in my own project I've made even another event class for UI events. So game events are all in the game class, but UI related events are in the UI class, and there are even more UI events typically than there are game events, because UI needs a lot of cross referencing and cross data. Yeah.
So would you also use events for stuff like changing scenes and I don't know, playing sounds or something?
Well, I would use it probably for changing scenes. I haven't done it yet. So fourth block was still developed on the old way, where I didn't know about the usefulness of this event-based architecture. Regarding to the playing the audio, I have my own custom audio player implemented. It just creates a couple of sound sources to the, or audio sources. Yeah, these are audio sources to the Unity scene, and then on request plays the audio. It definitely can be implemented through an event, but because it's such a common thing, I this one I'm doing through a static class. So I have this static class that I'm just calling sound. Nope. Sounds I'm doing so that I have a scriptable object wrapping the sound audios. So typically you also you often might need multiple sounds, like for the same click sound, you might need different variants that you are playing randomly, and you want to change the pitch and volume sometimes. So have this audio wrapper that allows you to tweak those sound settings, and I'm wrapping them in a separate data scriptable object, and then I'm giving this scriptable object as a reference to those objects. So I have this in shop I have this spy sound here, for example. That's the type of this sound data, this scriptable object, and this sound data scriptable objects also can have like methods. So for here I can have a custom method like public void play, and in this play file I'm implementing the playing the sound functionality. So by just calling this sound data or whatever hit sound.play will automatically play the sound. And yeah, I have multiple variants of this, like with vector 3 position and etc. What was it like understandable what I'm like kind of doing?
Yeah, I was just wondering if it was somehow better or to do it through events.
Yeah, the thing is that for the event you somehow need to know the sound file you want to play, and I've previously tried some systems where I did it string based, where I had this sound dictionary. It had a lot of strings and it played the corresponding string file, but it also get quite messy, and I changed the names of the sound files, and then I had some sound strings that pretty much like double defining your sound files with strings was not a good idea. So this means that I needed to have some kind of reference to the sound files anyway. So and because I already had this scriptable object for wrapping the sounds, that my objects need to have a reference to by adding this play functionality directly to the scriptable object was the right thing to do in this sense. Because you're already having it, you can just call it this one and play, and it will do everything else in the background. If you need to know about all the sounds you're playing in the scene, so some other objects might need to listen about them, then you might even want to add this custom event into the sound player there, and play it like on the background, like call this event on the background. So yeah.
One more question about the save system. How would you track like all of the objects in the scene? How would you serialize the objects in the scene? I mean, the coins, for example.
Well, to be 100% honest, I've had troubles with save systems myself in the past. I didn't know how to do it very well, and this is still a little bit like open question for me. I don't know what is the best way to do it. So what I might answer here is could be like wrong. So typically I would personally I would make this currently into this save controller, this custom method for just like creating all the objects from the scene file and removing them. That's probably what I would do right now. But there could be better ways of like doing it like automatically somehow. Yeah. saving game is a very tricky business. I've done it more in depth in Unreal Engine using some libraries, and even there it was like really complex stuff. So especially if you had those objects in the scene that you wanted to like remove and add back and make so all the other references will still stay working. It can get broken and messy quite quickly. Yeah. So there also I had some boxes that I wanted to save, but because other objects were holding the references to those boxes, these when I deleted and recreated them, they sometimes got broken. So I purchased multiple like quite like substantial saving systems, and none of them could do it like well out of the box. This dynamic object loading and adding very well. One of them was completely unusable, and second one I need to like edit the C# C++ code there and to make it like work, add those features so it would work as I wanted to. Yeah, so saving is quite complex stuff. Any other questions? All right, then I hope you got something for this quick show of some ideas of how to implement your games, and might try to use it in upcoming game jams. I have used this structure in previous game jam, and I was really pleased how well it worked for me, and it actually at the end of this game jam the project was much less messy than it usually is, and even though it got a little bit messy in the end, it still wasn't so messy that yeah, or it was other messy in other areas. All right, thank you very much, and let's end here. All right. Oli midagi muud ka või?
See on mingi Unity spetsiifiline asi või?
Ei, see on C-sharp. Ja sellepärast on kiire. Unity süsteem on üldse enda see, mis patroneid panin see